So anyway, if you do have the opportunity to take MATLAB, you should take it now while you're at Sierra College. Okay. And I think it's a very useful course because you get to learn how to solve problems that can't be solved analytically, by hand. Okay. So I want to begin with, I'm assuming you've seen the introductory video on Canvas and you've read the syllabus. Do you have any questions about the syllabus?
So in the syllabus, it mentions uploading a video to the Canvas site. I see, like, on your board, it says uploading videos to YouTube. Are you going to go over how to do that on the Canvas site too?
Yeah, I won't do the Canvas. I'm not going to do the Canvas one today, but I'll do it next time. I'll show you how to do Canvas because if you go on Canvas, if you go all the way on the left on your computer, there's a button that says Canvas Studio. And you can create videos on Canvas Studio with it. So,
oh, okay.
Okay, but I will talk about that next week about how to make the videos in Canvas Studio. Otherwise, create an account in YouTube, and you can take your videos and upload them to YouTube so that I can watch them. So when you upload your videos to YouTube, you have an option. You want it to be unlisted, private, or public. So my lectures, I make them public because otherwise I have to send a link to all you guys every time I upload a video. So you guys can make your YouTube videos, make them private, send me the link, and I'd be the only one who can watch it. Okay? Last semester when I had students make the videos, they would upload files or email them to me. And to download the files onto my computer took a long time. I had some students make very long videos. I mean, some of the files are 3 gigabytes. I don't want to spend 45 minutes to an hour just downloading a file. So that's why I'd rather have you upload it to YouTube or use Canvas Studio and for the videos. Okay. There's going to be 5, and I'll mention them a little bit later. There's going to be 5 labs where you're going to use Canvas Studio. I'm sorry, or YouTube. Okay, and then there's going to be 5 other labs, and that includes this activity, which you're going to do something written. Written meaning you're going to type it up. Okay. Is that okay, Christopher? Okay.
Yeah.
Other questions?
When are the lab kits going to be available to pick up?
Okay, that's a good question. So I spoke to Tyler yesterday, our instructional assistant, and I spoke to the bookstore. So I have to give them, so you can go ahead and order them. I have to give them your roster, the course roster. And I told them I'd give it on Monday. So I'm going to give them the course roster on Monday. And hopefully I won't have any changes after that. And then they're going to process the orders based on who's left in the class. Usually, you're not going to have too many people leave the course by Monday. And then they need to process it. So I said, you guys will probably need the equipment by the beginning of the 3rd week. So on the 8th of February, you'll be able to pick them up. Okay? So that'll be the day you can pick it up. Now, I know that based on what I heard this morning, you have the option, they give you the choice whether you're going to pick it up or have it mailed to you. If you choose to pick it up, I would just let them know. I would contact them and say, I want to come on this day to pick it up. Will I be able to do that? And one of the issues I'm worried about too is, the social distancing that we have to deal with. So I would, if you're going to go pick it up, contact them. But it won't be until the 8th. Okay, Monday the 8th.
Yeah, I wonder because I needed to pick up some other lab kits, and yeah, they said that for physics, I couldn't pick it up yet.
Okay.
But yeah.
Yeah, I just want to make sure that if you check the box that says you're going to pick it up, you let them know ahead of time so that there's no mix-up. I'm just trying to avoid mix-ups.
Okay.
Yeah.
Yeah. They were okay with it though. Like when you go there, if you just let them know what class are you in and stuff, they'll just like give it to you.
They'll just give it to you. Okay. Okay.
Yeah.
Okay, good. Yeah, and so I should say, we're going to start a lab next week. And I'm quite confident that the equipment that you need for the lab can be obtained for stuff you have at home. So for example, you're going to build something called an electrophoresis, which is used to demonstrate properties of charge, electrostatics. Basically, you need really a paper plate, aluminum foil, and a paper cup, and some glue. Okay, and then you're going to build something called an electroscope, which is used to detect electrostatic charge. And you need a jar, some aluminum foil, some string. So I'm assuming you have this stuff at home so that you can build the equipment at home. And then the other thing though is you have to show me in the video that it works. And so you have to find a way to charge things. And one way to charge things is if you have something out of styrofoam plate, styrofoam cup, and maybe some fur or even wool. You rub them together, you can produce some electrostatic charge. So I'm assuming you have that at home. Now the lab kits also have items for which you can produce electrostatic charge. So I'm hoping you won't need it for at least this first lab, because I think most people have styrofoam plates or whatever. Okay, but if you think you're going to need some of that equipment, then you probably want to pick up everything on the 8th. Okay. And just remember that these are things a lot of the stuff you want to bring back at the end of the semester. I mean, that kit's over $200. It has scopes, meters, all kind of stuff. Okay. So I hope I answered your question, Mikhail. Other questions?
Yeah, you did. Thank you.
Okay.
On the lab kit, like I'm assuming we're going to get a multimeter and all that stuff. If we have our own multimeter, our own personal one, can we use that one instead? I know, like in 205, when I got a veneer caliper, like I had my own, but she wanted me to use the one out of lab kit.
Actually, if you have your own, it would be very beneficial for the last lab of the semester if you use your own. So yeah, go ahead, and if you want to use your own, that's fine.
Okay.
You just need to let me know. Just inform me in the lab that you use your own.
All right.
Okay. Yeah. So regarding the multimeters, one is a good multimeter. One is not as good because trying to keep the cost down. But that does affect us in terms of our ability to do some of the labs. So the last lab, ideally the last lab, you need 2 multimeters. But the second multimeter that comes in the kit doesn't measure AC current. So it's a cheaper one. So you're going to have to use one single multimeter to do the whole lab, which makes the lab take a long time, unfortunately. When you do the lab on campus, we have 5 multimeters, and you use them all at the same time. So, and that's us trying to keep the cost down. So, other questions or concerns? Okay, so all my lectures. So this will be the time where I talk about the labs, the experiments, what you need to do to get the experiment completed. Now, I also have Tyler, he's created some videos of some of the experiments so that you have something else to refer to. He's on campus. He's using the equipment on campus to videotape everything regarding the lab. So you'll see higher quality videos from him demonstrating the equipment. I'm kind of limited. I'm in one room in my house trying to demonstrate some of the lab equipment, which makes it a little bit difficult. So I'm hoping that his videos will help you a lot. I do expect that I'm going to have a lot of questions on the labs, and so that's why I sent you the link to the Discord, and I expect you to use the discussion board to ask questions. So one student brought up a question in the previous section, what about lab partners? Well, because of COVID, we can't have lab partners. So the big thing here is we're going to be doing labs on our own. Okay, and so that does present a challenge, because it does help when students work together and doing the lab, but we won't have the ability to do that here. Okay, but feel free to communicate with each other during the semester using chat, Discord, discussion board, whatever. Okay. What if you're immune? Well, if you're immune, not everybody's going to be immune, though. Okay. Let me talk about some expectations about for this class. There's going to be about 10 items, and I might be miscounting, that you're going to be turning in this semester. Five are written, meaning you're going to type them up. They're going to be done on a word processor, and 5 will be videos. So let me tell you the 5 that'll be done on videos. Okay, so one is you're going to build equipment for the properties of charge lab. And then you're going to do the properties of charge lab. So these two, the lab is basically you're going to observe and explain. So there's no really analysis of data in it other than you're going to observe a phenomenon and try to explain it in terms of items that we discuss in class. And so you're going to create videos of these. This first one, the video shouldn't be very long. Okay, the second one will be significantly longer, hopefully not too long. Okay.
And when we submit this one, do you want it in 2 videos, or like should we add the second part onto the end of the first video, or just 2 videos?
You can do it however you want. I mean, this one has like 4 parts or 5 parts. If you want to make a single video, that's fine. If you want to make multiple videos, that's fine also. I really don't care. I'm trying, I don't want you to spend a lot of time on developing videos, but I want you to be able to just demonstrate things to me. So,
okay.
Yeah, however you want to do it, that's fine. Last semester, there were some people who made some just awesome videos, who knew, you could tell they have experience making a video. Some people don't and didn't, and so they would just do one part, video it, and then create a second video for another part, etc. And I'm fine either way. Okay, so I'm pretty flexible with that, because I don't want you to spend time making a fancy video. Okay. Then there's something called the multimeter lab. And basically it's an exercise where you're demonstrating how to use the multimeter. There's a set of exercises, there's like 5 parts to it, where you're just going to show me that you can build the circuit. There's several circuits you want to build. You're going to show me that you can measure voltage, current, and resistance. Okay. And granted, some of you folks do have experience with this, so this is going to be pretty easy for you. But for some of you, you've never done this before, so it's going to take a little bit more time. Okay. Then there's one called an oscilloscope quiz. Again, another video where you, and this is probably the shortest one, where you demonstrate to me that you know how to measure voltage and period of a signal on an oscilloscope. These are not fancy oscilloscope, okay? They're like, you know, they're like this big. They're like 25 bucks, but they do the job for us, okay? They do the job for us. When you're on campus, we have these big monster ones that are analog, they're 500 bucks, okay? And then the last one, DC motor. We're gonna give you a motor kit in the lab kit. Basically, it's a board, some nails, wire, and you're gonna build a motor. And the goal is, your goal is to build a motor, and you actually have instructions on how to build it. But you wanna build it so that it runs at 3 volts or less. Anything at 3 volts or less gives you an A. Okay, when we do it on campus, it's 2 volts or less. Question or? Yeah, the way I grade it when the course is online is a little bit more lax, just because when you're on campus, we have nice equipment that you can use to test the motor, and then you have us at your disposal.
Are we able to change anything like on the motor itself to make it more efficient, or are we limited to what we got?
You can add bearings to it. There are some restrictions. You gotta wire in series, not parallel, because it makes a big difference. Your armature has to be a certain dimension, etc. Okay.
Okay.
But yeah, you can modify it, and some folks just go to town on this project. The engineering folks really go to town on this project. So all of these are going to be videos. I don't know, this I expect to be short, because you're going to show me that it works at a certain voltage. That's all I need to see. And oh yeah, and in all these videos, I got to see you in the video. I need to see your face. I need to see that you did the experiment. Okay, that's the one big requirement. I need to see you in the video. Okay. Then the other ones, the other activities are all written. So the first one you see in the left-hand corner of your screen, this is a review sheet, basically. There's really, this semester, 3 labs where you're going to be doing the full data analysis with air propagation and all that fun stuff. Okay, but you still got to do it. So you're going to be doing, 210 is a little bit different because you're learning how to use the lab equipment. So let me go over some of the things that I expect. And it's in the syllabus, but I just want to remind you. Okay, so your lab reports, the written ones, what I mean is they're typed up on a word processor, whatever word processing software you use. Okay, so you're going to write a lab report and you're going to upload it onto Canvas. Pretty much like you did in physics, those of you who took 205 last semester. That's how you're going to do it. So everything must be typed up. The only exception might be a figure, if you have to draw a figure, because not everyone's proficient at drawing figures on the computer. I mean, if you've had engineering 22A and 22B, you should have no trouble drawing figures on the computer. Okay. Anything that's handwritten on the lab, I'm gonna deduct points. Late lab reports, if you turn in a lab late, it's 15% per day. You get deducted 15% per day all the way up to the end of the semester. And that avoids students turning in a whole bunch of labs at the end of the semester. The lab reports in general, the weight of the lab reports are varied. They're either worth 20 points, 25 points, or 40 points. The only one that's worth 25 points is what's due next week, the review worksheet. The other ones are either worth 20 or 40. And the reason why they're weighted differently is because some require a lot more work than others. Okay. I will say that the grades on the video labs tend to be higher than on the written labs. Because on the video labs, I'm just trying to, I'm looking at Did you demonstrate the phenomenon? And in some cases, did you explain it? Really, that's it. Okay, so for these two, if you demonstrate everything you need to demonstrate, you'll get full credit. Okay, for the multimeter and oscilloscope, you'll get full credit if you demonstrate everything you're supposed to demonstrate. Okay. All right. Graphing is an important thing regarding graphs. We will have lab reports. You're going to be creating graphs. You did this in 205. The graphing software that you use is important because the graphing software that you use has to do curve fits, provide the results to the curve fits. It's got to give you the curve fitting parameters, but also the uncertainties in the curve fitting parameters. So if you do a curve fit with parameters A, B, and C, like you did in Physics 205, your software better give you the curve fitting parameters plus the uncertainties. The reason why I'm talking about saying this is because last semester I had some students go to the graphical analysis website and download their version, which is the newest version. Their newest version does not give you the uncertainty in the curve fitting parameters, and you can't do any error analysis. The old version, which is usually on our computers in the lab, does do that. Those of you who had Physics 205 last semester, what did you use for your curve fitting? Did you use Cy Davis? So that's another one. Okay, so if you use Cy Davis, that one's free. That one's free, you can use that. If you find another one, there's a bunch of them that are free online. I think there's one called SciMath, but that one's the analog of MATLAB. SciMath does the same thing. It's free. So you can use whatever you want to use as long as your software gives you the uncertainty in the curve fit parameters. If you're in a bind, Pasco has a software called Capstone. And you can get a free 30-day demo. It's only for 30 days. You can get a 30-day demo on Capstone, and it does nice graphs. Okay, so that's another software you can use. And you get it for 30 days free. Cy Davis, be careful with Cy Davis, by the way. Has anybody used Cy Davis on the Mac? Because I've had it disappear on me and I have to reinstall it every time. On the PC, it's okay, but if you move that file that you download, the whole thing disappears. And so you have to make. I keep it on my desktop now, so that I know it's there. Because otherwise, it disappears. On the PC, it's not a big deal. But SciMath is very powerful. Okay, it's a very powerful software, and it is. Granted, it is in a beta version right now. Those of you who are computer folks, the one that you really want to use is the one that runs in Linux. Okay, that one works well. Okay. So anyway, the graphs have to be done on the right graphing software. One of the issues that I've had in the past is students turning in labs from a previous semester. I call it dry labbing. If I see something like that, that lab report is going to get a 0. Or if you turn in lab data that's made up, you're going to get a 0 on the lab. Okay. By the way, I change the parameters every semester. So in the lab kits, a lot of the material in the lab kits that you see this semester are different from last semester. Okay. I don't drop labs. I mean, and I'm biased. I'm an experimental physicist, so I think the lab is an important part of learning physics. So you need to do all the labs. Okay. Let me just show you the because I didn't show you the Canvas page in class yesterday. Let me just show you the Canvas page. Just give me a second to switch views. So a number of you told me this morning that you cannot see that picture on your Canvas page.
Yeah, I cannot.
Okay, so
Yeah, I can't either.
I'm going to look into this, but you can see the picture on the main course page, correct? In other words, let me go to the main course page.
Yeah, all the people.
Yeah.
Yeah,
Yeah.
I can see that.
Okay.
Just there's a big old lock right where the experimental physics at Berkeley National Lab picture is.
Okay.
Yes, same for me.
I gotta, okay, I'll look into that. Yeah, anyway, I'm hoping you saw a lot of this. I have the links to the modules, but let me just show you the modules. And all the pages are set up the same way. So I'll go to the modules page. And so there's, for example, for this first week, there's a bunch of documents. A lot of them is review, but that I would like for you to read or reread if you don't remember stuff like Sig Figs. There's a handout on Sig Figs. There's a handout on air propagation. This is actually, if you had Aviva, this is Aviva's document. And then I have this link on lab report reminders. These are like my pet peeves for lab reports. So you probably want to go read through this. Okay, it's there. It's always there for you, so you can take a look at it. Okay. So all the modules are here. Some of these modules have videos on them for the properties of charge lab. I actually have a video you can watch on properties of charge. There's this guy at MIT who does a great lecture on properties of charge. So I have a link for it. So every module has either documents, videos, and of course the report you need to write up. So here's a lab report worksheet. And you want to type this out. You can get those lines there just to tell you, put the answer there. You can get rid of those lines. I don't care. All right. Because 3 pages, it's not a very long one. You're not making any measurements. It's just on stuff that you should know already. Okay. And again, the main course, the 210 course, is set up the same way. Okay. Let me go back to the other document. So this will be due next week. This is the review worksheet that will be due next week. And so basically it's a review on Sig Figs, air propagation, things like that.
Quick question, but it's about just the main course. I saw that you uploaded the answers for the conceptual questions.
Yeah.
But I didn't see the file for the conceptual questions.
So I only have conceptual questions for units 2, 3, and 4. So if you go to units 2, 3, and 4, you'll see them. And for the last unit, I've been trying, it's just hard to write good conceptual questions for the last unit. And then for this first one, it's a unit that I hardly ever have time to cover. Usually it's a unit that don't have time to cover thoroughly, except for this semester, because I'm starting at the beginning. Usually I cover this at the end of the course, and so there's very little time to cover it. But yeah, I haven't developed the conceptual questions for 2 of the units, unfortunately.
That's okay. Thank you.
Anyway, this document, you just type everything in and submit the report. Submit this next week. So this will be worth 25 points total. And it's just a review. So let me talk a little bit about this document. Let me switch views here. So just a review, a fast review on Sig Figs. There's a document on Canvas regarding Sig Figs. So if you need to review it, please go through it. I do look at Sig Figs in your lab report and uncertainties and all that stuff. Okay, because as a scientist, it's important for you to not only make a measurement, but report how well you know the measurement. So, what are the rules? At least for how to do operations. And, you know, the rules for Sig Figs pretty much only work for addition, subtraction, multiplication, and division. If you're using trig functions, the rules for Sig Figs don't work. Okay? So if you're going to add or subtract, how do we deal with in terms of rules for Sig Figs? Well, we got to keep the least numbers, at least number of decimal places. And I ran out of space. Okay, you go by the least number of decimal places. So, for example, if you're adding 2 numbers, the top value has 4 sig figs, the bottom value has 1 sig fig. How many are my final answer? Well, I go by the least number of decimal places, so I go to the 10th place. So my final answer is going to still be to the 10th place. So yeah, I will gain a sig fig. So when you add, you can gain sig figs. When you subtract, you can lose sig figs. Okay? Hey, Tyler, just keep your comments focus your comments onto the class. Okay, Tyler? So if I wanted to subtract, if I did this, I have 5 here, 4 here, and it gives me 1 sig fig. Okay, so I can gain sig figs or lose sig figs. Okay, so if I do something like this, I actually got my final answer is to this decimal place, and then whatever it is to the left. Okay, so I always go by the least number of decimal places. Of course, this is if I'm adding this. Okay. Questions on the rules for adding or subtracting? Okay. What about multiplying and dividing? What do we do if we multiply and divide?
Least number of sig figs?
The least number of sig figs. Okay? We go by the least number of sig figs. So if I multiply two things like, let's see, 2.37, 1.225, or times, my final result has to have 3 sig figs, if I remember. Okay? I don't want to keep the next digit because that's telling me that what I'm calculating, I have more trust in what I calculated than what I measured, which doesn't really make sense. So whether we're multiplying or dividing, we go by the least number of sig figs. So I'm hoping you remember that. And so, and I'm going through this quickly. The document that's on Canvas is like 6 pages and goes through it into extreme detail. What about if I'm dealing with multiple operations? So let's say I do the following. Oops. Okay. What's my final result? Anybody want to guess what my final result is going to be?
2 sig figs?
Yeah, this was a hard one.
Or like 1 whenever you subtract it?
So you want to subtract first, right? So according to the rules for sig figs, when I subtract these two, what do I get?
0.
0. So my numerator is 0.
So just 0?
It's just 0. So I know it looks weird, right?
Yeah.
But this is how I interpret it. And I interpret it this way. These two values agree to 2 decimal places. Okay? These two values agree to 2 decimal places. That's all it's telling me. That's fine. It's not saying, I'm not saying that the error is 0, but I'm just saying that to this place that the two numbers are equivalent. That's the only thing I can say. Okay. Now, what if I do the following? Let me change this. How about now? How many sig figs? I gotta do a subtraction. Is it true that this subtraction is only going to give me, actually I got to stop here, right? It's only going to give me 1 sig fig. The numerator will have 1 significant figure. Denominator has whatever. So now we're going to have something with 1 sig fig. Whatever that turns out to be. Now, here's the thing. When I subtract these two, what's the rule for subtracting? Or what's the rule when that last digit is a 5? I'm sorry. What's the rule when the last digit is a 5?
You round up.
You round to the nearest even.
Yeah.
You better be careful. Only if this, you only round to an even. If you were going to round to an odd, you would keep it. So you round to an even. Okay, but when I do this calculation, should I round up or should I just leave it like this? Or should I just do the following?
Round up since the one's not even.
I know my final answer is going to be 1 sig fig, right? True, right? I know my final answer is going to be 1 sig fig. But
Yes.
typically when you do multiple calculations, the rule is to keep an extra digit in the intermediate calculation and then round off to the proper number of sig figs at the end. Does that make sense? The rule of thumb is, because you lose accuracy, if I round this off here to 2 and then I do the calculation, I'm going to lose some accuracy. Especially if I have to do more than one calculation. If I had to stop here and just do the subtraction, I would write 0.002. But because this is an intermediate calculation, then I'll keep an extra digit for the next calculation. Okay, that's the rule of thumb. We okay with that?
I have a quick question. So then, why in the other example?
I'm sorry? Why in the other example I just said 0?
Yeah.
Well, okay, so let's go back to the other example. So let's say I subtract these two. And I get 0.0059. Okay? There's no sig figs in the answer. The number of sig figs in my final answer is 0. Right?
Right.
So if the number of sig figs in my final answer is 0, I don't have to do the next calculation because I know the answer is going to be 0.
Oh, okay.
Right? Right. Okay. So are we okay with this? Let me do another one that comes up often that causes problem because you will have different faculty members say different things about this, and this is what confuses students. So let's do this. Let's say I measured something 4 times. I'll use centimeters. I chose nice numbers because when I add them up, what do I get? And so I want to calculate the average of those numbers. So I take 10.00 and divide by 4. The 4, like the 100%, is a counting number. So counting numbers can have as many sig figs as you wanted to have. But if I apply the rules for sig figs strictly, then my average value should be written this way. Now, have you had an instructor who's told you not to do this, just to keep it like this? I mean, some instructor will say, well,
Yeah.
You've gotten people to say that, right? To just keep, since these numbers are at their 100th place, then why add the next decimal place? But then my question is, what's the purpose of measuring something multiple times if it doesn't reflect higher precision? Now, the point is, it's debatable either way. I mean, either me or the other instructor can be correct. How do I figure out the answer? Well, I use the theory of error. I actually calculate the uncertainty in this thing. By calculating the uncertainty in this, I can figure out who's correct. Because if the uncertainty is to the thousandths place, then I was right. If the uncertainty is to the 100th place, then I was wrong. In other words, the answer is going to depend on what the spread of these values is. This is why the rules for Sig Figs are just a set of guidelines. Sig Figs are for people who have not used the theory of errors, or who haven't learned the theory of errors. So like in high school, you don't learn the theory of errors, for example, okay, because it's too complicated. And so we use these rules for Sig Figs, and they don't always work. So here's a case where it doesn't always work. But I can figure out the answer by first calculating the standard deviation in the measurement, which you remember as the square root of 1 over n minus 1 times the sum of I equals 1 to n of x sub I minus x average squared. So x sub I is one of your measurements, and then x average is the average of all the measurements. This is going to tell you, well, not this, the next item, the uncertainty, which is the standard deviation over x, over the square root of n. This will tell you whether you're right or not. So this is called the uncertainty or the standard error. That's why in this class we want to use this, because this tells us whether that's correct or not, okay? So if this uncertainty, remember you only keep one digit in an uncertainty because this tells you what the doubtful digit is. If you if this is to the thousandths place, that means you keep your average to the thousandths place. It's a reflection of how consistent your measurement was. Okay? And you did this in physics 205. Now, suppose we measured x, y, and z, whatever they are. We measured three quantities. I'll call them x, y, and z, whatever you want to, whatever they represent. So we made a bunch of measurements on x, we made a bunch of measurements on y, and we made a bunch of measurements on z. And from that, we calculated the average of x, the average of y, and the average of z. So an example would be the length, the width, and the height of a block. So we know the average value and its uncertainty. We know the average value of y and the uncertainty. Same thing for z. Okay? Now, with these numbers, for example, if they're the length, width, and the height, maybe I want to calculate the volume. I want to calculate something that's a function of x, y, and z, which I can do. But what is the error in that? How do I, and it's an estimate, right? What is the estimate of my error in the product of those three numbers, for example? This is where error
propagation?
Yeah, this is where error propagation comes in. You're right. This is where error propagation comes in. And so the uncertainty is calculated using this formalism. I got to take the derivative of this function, whatever that function is, with respect to x, and square it. And you guys are familiar with the symbols here, right?
Yeah, partial derivatives.
Partial derivatives, okay. Basically, all I'm saying is, if you haven't had Math 32, you take the derivative of a, just varying x, and just assume y and z are constant. And you do the same thing for y. And you do the same thing for z. And in the equation, you put the average values of the functions. Okay, when you actually plug in a number. And then you put your uncertainties. And your final answer is 1 sig fig. Your uncertainty is always 1 sig fig at the end. Okay. And this will give you the uncertainty in A. So those of you who had physics A with me, we actually did this, except that in physics A, I didn't write this equation out. In physics A, I said, I gave you the actual equation you got to plug in. But now that you've had calculus, you can derive everything yourself. Okay, so on the second page of the worksheet, I'm going to have you practice on this. Okay, the second page of the worksheet has you practice on some of this just so that you remember this stuff. Okay. Some of the items in there are things that we will be using several times a semester. Some of those equations. I think one of them is related to your Archimedes principle lab. Okay. Okay, so, and I think you're all familiar with how to do this calculation. So we're going to do the same thing here. I want to say a couple of things. And when you report a result, anytime in this course, when you report a result, you should always associate it with an uncertainty. So if I measure something, let's say I measured the length of an object, and let's say I write 3.58 plus or minus 0.05. Notice how I wrote it. I put in parentheses and put the centimeters out there. You can do this if you want. There's more work. That's okay to write it like that. But you should always quote the value and the uncertainty, because anytime you make a measurement, your measurement doesn't reflect a single number. It reflects a range of values. Any measurement that you make reflects a range of values. Okay? All right, so what some people do sometimes is this in your lab reports. What does that imply?
That the uncertainty doesn't have any units.
Yeah, it does, right? It does have units. So you want to imply that this thing has units in it. It's got to have the same units as what you measured, because this reflects how well you know the measurement. So if the measurement has units, this has the same units. Okay, so you want to get away from writing things like that. I mean, this is okay, just more writing for you. Okay. Now, students do the following too. Why would that bother me?
Scientific notation.
Yeah, just write it in scientific. Why? I mean, I have to count decimal places.
Too many zeros.
Yeah, there's too many zeros. Okay, so what you want to do, and this is probably the best way to do it. This is not technically, this is kind of like scientific notation. It's not exactly, because usually when you write a number in scientific notation, the number in front of the multiplication sign is a number between 1 and 10. But I'm going to break that rule here just for convenience, and I'll show you what I'm going to do. So this is 1, 2, 3, 4, 5. So this is times 10 to the minus 5. I actually would write it like that. I know some people will do this. Which is easier to interpret, the bottom one or this one here?
Top one.
Right? Isn't this one easier to interpret?
Yes.
So again, you're trying to make it easy for the reader to understand things, right? When you're writing a lab report, you got to get away from writing to yourself, but think about how someone else is going to understand what you said, which is hard. I mean, I do it. I still do it now. It's a hard thing to do. So there's little things we can do to make it easier for the reader. So this is one of them. So if you look at a scientific journal and you look at a measurement, they're going to quote it like this. Even though technically this is not a number between 1 and 10, because in scientific notation, this has to be between 1 and 10. But they let that go when you're dealing with when you're quoting an uncertainty. Okay. So I prefer that. In fact, some students will do this too. They like doing the extra typing. So if you want to do extra typing, you can write it like that. And this is not wrong, it's just inconvenient. So let me tell you about one of my pet peeves. We all know that if you type in Microsoft Word can do subscripts and superscripts, right? So when you write a number in a measurement in scientific notation, all right, don't do this. Okay, and especially don't do this. What does this mean? Is this 2.718 times 10 to the fourth? Word or whatever word processor you're using can do superscripts. So write things in superscripts. Okay. Because otherwise, I will start docking points saying format on your lab report. Okay, that's one of the things that's kind of bothersome. What's the difference between precision and accuracy? This is a review. What's the difference between them?
Isn't accuracy how close you are to a known variable, and then precision is how often you can replicate it?
Yeah, so this reflects consistency. How about if I write it like that? So this reflects, so what you said is correct. It reflects consistency. And this reflects how close you are . And we might never know the true value. Okay, we only know approximately what the true value is, but we don't know exactly what the true value is. Okay. So if you're do the dartboard example, you throw darts at a dartboard, and your darts land there. You're consistent, you're precise, but maybe when you put your glasses on, you become accurate. And the reason why is because your glasses produce something called a systematic error, right? And so by correcting your systematic error, you're on target. What are the 3 types of errors in an experiment? I said one of them already, right? What are the other 2 types of experimental error?
calculation error, right?
That's a blunder. So we'll call that a blunder.
All right. Well, I have a lot of blunders then.
And then random. These are the three sources of error in an experiment. There's a systematic error, which makes your value either consistently larger than it should be or consistently smaller than it should be. A random error makes your results either sometimes bigger than what they should be, sometimes smaller than what they should be. Okay? And then this just means you screwed up. You made a mistake. And so these are what you want to eliminate. Okay, you want to eliminate these kind of errors. Okay, you get rid of those. And if you're worried about an error in a calculation, for example, you can always ask. Okay, so this is something you want to get rid of. Now, systematic errors you can get rid of if you redesign the experiments. Random errors you can't ever get rid of because they reflect the precision of your instrument, and there's no instrument that's 100% precise. So, if you do an experiment, at least at Sierra College, how do you know whether your systematic error or random error dominates in your experiment? Or what would indicate that you'd have, for example, systematic error dominating in your experiment?
Wouldn't you just look at your averages?
Yeah,
And
let's say, go ahead.
And if your averages are always above or always below, then it's a systematic error. But if they're like pretty evenly spread between the two, then it'd be random.
Yeah, in fact, if you want to be a little bit more precise, if you count, let's say you measure the density of aluminum. Let's say this reflects the density of aluminum. You did this measurement, okay? And the accepted value is this. Your range of values does not include this. Now, when you do your experiment at Sierra College, this number is reflective of random errors. We don't have the ability at this point in our classes to be able to estimate the size of systematic errors. That's actually very difficult. When you become an engineer, you'll be able to do that. So this number reflects random errors. So my random errors do not incorporate this number. So this suggests, I'm only saying suggests, this suggests that systematic error dominates. Does that make sense? I can only say suggests, right? I can't say for sure. Now it's harder to if this number was, now it's much more difficult to say whether random or systematic errors dominate. I would say that because of this number is pretty big and it incorporates it, most likely random errors dominate. If my value was in the range. Does that make sense? These are kind of questions that are going to be asked in the labs. And if you look on page 3 on the assignment, I ask questions like this. Okay, so this is kind of a review for you all. And on the written labs, you're going to see very similar questions to this. So I just want to make sure you understand. Okay, I'm really looking for, this is the way you want to think things through in the lab. You're going to be asked, does your measured value agree? Well, when this was a 0, when this is a 0 and the range of these numbers doesn't incorporate 2.7, then they don't agree. There's probably systematic error involved. That's what you would just say. And maybe you can figure out or allude to what the systematic error is. Any questions or concerns? So this document, this worksheet will be due next week. And I usually have the due date, the time's like 11:59 p.m. Okay, so it'll be due next week. If you have questions, don't hesitate to ask. It's a review. And then next week we'll start our actual lab, which is you're going to be building something for me. Okay, and you're going to make a video of it demonstrating that it works. Okay, so that's all I have to say. If you don't have any questions, I will see you at 2 then.
I have a question real quick.
Oh, go ahead.
Sorry. Whenever I was looking through the module and I was just waiting for a good time to ask, do you have your own lab cover sheets, or would you just like us to recycle one from 205?
When the course was on ground, and you guys handed in labs, I would have you guys include a cover sheet. It doesn't matter to me. Some people like putting a cover sheet, that's fine. If you want to recycle an old one, that's fine.
Okay, so you don't require cover sheets online?
No, not when the
Okay.
course is online, not when you submit everything online. It's just another thing to add.
Okay,
Yeah,
thank you.
sure. Anything else? All right, we'll see you at 2 then.
I
Thank
think
you.